Okay, so we need everyone quiet because this is going live on YouTube. Okay, so lesson number 3. Today we are adding and subtracting rational expressions. And if you notice, this is part 1. So today's kind of like the easy stuff, and then tomorrow to get harder. So really use today's homework time to work on the homework, because if you have problems with what we're learning today, tomorrow is going to be really difficult. Okay, so as a review, they have addition and subtraction of rational numbers. So we can remember that rational numbers are just fractions. Okay, so this is a review of how to add and subtract fractions here. So this might be something really good to put on a study sheet. When I taught grade 7 last year, I taught them how to add and subtract fractions in my first practicum. Okay, so this is something that you guys have learned for 5 years now, and this is something that I still see mistakes on the quizzes and tests all the time. So we're going to review it, and it might seem silly and easy, but I don't want to be marking test questions wrong because you couldn't add fractions properly. Okay, so the first step is always determine that lowest common denominator, or the LCD. And then before you can add them, you have to make the fractions have the common denominator. So you might have to make equivalent fractions. So for example, if you have a problem like this, you know that you have to make it like 2 over 4 plus 3 over 4. And then you get to combine them. So that's when you go like this. And then reduce to lowest terms. It'd be like 5 over 4. Like that. Okay? So if you don't understand, you can put up your hand or ask a question, but we don't need continuous comments. Okay? So I would suggest that if you have a study sheet, put these steps on there, maybe even write little examples like this beside it. Okay? So then we're just going to do a few that just have rational numbers, so just like normal fractions. So we'll do all 3 of these really quickly. So 2 over 3 plus 2 over 5. Can I please have someone put up their hand and tell me what the lowest common denominator is? Kevin? 15. Perfect. So then to get 15, you go, okay, multiply by 5 on the top and bottom here. On this side, we want to multiply both by 3. So we get 5, 2 over 15. Then we get 10 plus 6. And then you can also put it in like a mixed fraction. Okay, so once you find your lowest common denominator, whatever you do to the denominator, so say for example with this one, to get that lowest common denominator, you also have to do to the numerator. So we say, okay, our lowest common denominator is 15. So for our first term, I multiply the bottom by 5. That means the top also has to be multiplied by 5. And then the same for this one. We say, okay, we know the denominator has to be 15, so both the top and the bottom get multiplied by 3. Okay? So can I have someone put up their hand and let me know what the lowest common denominator for B is? Oh, Justin. 12. Perfect. So we know to get 12, we go, okay, well, 6 times 2, which means we also have to multiply 5 by 2, and then both of these by 3. So we'll get 10 minus 3 over 12. 7 over 12. It should be, because this is like, pardon? Yeah. This is like I said, this is like grade 7 and 8 stuff. So this should feel easy and maybe like a little bit silly because it's so. Okay, so last one here. Do you wanna? Okay, let's hear it, Josh. 24, you got it. So we know, okay, so this multiplied by 3, this one by 8, and this one by 2. So we know we get 21 minus 16 plus 10 over 24. Which gives us. Okay, so are we done? What would we do next, Kelsey? Yeah. So we can, perfect, divide 3 right out, and we get 8. So, just like on the last section, when you get to the end, always make sure that it's in the simplest form possible. So you want it in that kind of form. Okay, so let's move on to something that's a little. So yeah, exactly. So these types of questions you guys know how to do in your calculator, which is why these types of questions will not be on like your quizzes. Like the type that doesn't have any x in it. Okay. So, yeah. So if we move on to example number 2, we're going to do A and C. And so now you can see that we do have variables in the numerator. But we still start the same way. So you want to put up your hand and let me know what the LCD is. Yeah, Daniel? 20, perfect. So same thing, so times 5, 4, and then this term all gets multiplied by 2. So we go, okay, so 5, 3x plus 4x minus 2, 7x. So just be really careful, especially once you see a minus sign there, that you don't forget about that. And then we get, okay, so 15x plus 4x minus 14x all over 20 equal to 5x over 20. And then we can simplify that to x over 4. Yeah. If you had like that. Yeah, absolutely. Even on a written response, I would take both of those answers. No. Okay, so if we look at C, what is our LCD? Can someone put up their hand and let me know? Yeah, Kevin? Yeah, 24. So we just do it the exact same way. Multiply both the top and the bottom by 3 in the first one and then by 8 in the second. So we go 3 minus. So when we get into questions that are more complicated, even like this one where we have a binomial on top and we have a negative, when I'm simplifying them, I'll usually go, okay, so 24y minus 9, and I'll keep it in brackets until I've put like this 8 in it. Because lots of people will say, oh, if I multiply this by negative 8, almost everyone gets negative 16y. But a lot of people will forget that the negative also goes with that 1. So I usually like to keep it inside the brackets and then do that negative very last. Y plus 8, like that. over 24. And then I would go, okay, so that's 24y minus 9 minus 16y minus 8 over 24. So I think people are just less likely to forget about that negative if you kind of do this as two different steps. Okay? Yeah, the negatives screw people up. Okay? And then we get 8y minus 17 over 24. Can this be simplified? Yeah, no GCF. Can't simplify it. Final answer. Okay, so let's flip the page. So for example number 3, these ones aren't really different from example number 2. So all I'm going to point out is if you look at them, we have some terms that aren't rational numbers. But you can make this into a rational number really quickly, right? Yeah, exactly. So you just put it over 1. Just like that. So because those are really similar to example number 2, I'm going to skip them. Okay. So then we'll do A and D. So for these ones now, the denominators have variables in them, but for example number 4, if you notice, they're all the same. So that makes our life really easy, even though that there is a variable in it. So they ask us to express in those terms and indicate non-permissibles. So we know that the first thing we do is find those non-permissibles, and then we simplify. So what's our non-permissibles in A? Yeah, exactly. So x cannot equal 0. And then we go, okay, so that's 2 plus 7 minus 1 all over x. And then we get 2 plus 7 is 9, 8x. So our restriction and our answer. So if we look at D, it's the same thing. Our denominators are already common, so we can go, okay, 4x plus 10. And like in the previous one, because these are binomials here, I usually stick them in brackets first, just so I remember to distribute that negative sign. Because someone will forget to make this a negative 4. Yeah. And if you know that you'll always remember to do that, you don't have to put the brackets in. Okay, so minus 2x minus 4 over x plus 3. We have 2x plus 6. Okay, and then so this one you can see that we have a GCF in the top. So we have 2 times x plus 3 over x plus 3. So we can cancel these out. And we get our answer to be 2. But we haven't found our non-permissibles yet. So you have to remember that our non-permissibles always come in before we've simplified anything. So I don't want anyone to be looking at this and say, oh, there is no non-permissibles, because the answer is 2, right? So, oh, yes, Justin? So a non-permissible, we learned last class, is where the denominator equals 0, because you can't divide by 0, so you know that whatever makes the denominator equal 0 is not a solution. So I always start, I go, okay, x plus 3 cannot equal 0. So then you can go and subtract 3 from both sides. X cannot equal negative 3. X can equal anything in the world except negative 3. Yep. Yeah. Yeah, so you always want to find your non-permissibles first. Okay? Yeah. Okay, so we go to example number 5. We'll do A, B, and D. So you can see that these questions as we get going are just like a little bit more complicated each time. So this time our denominators aren't the same in both. So this is where we have to go, okay, what is our LCD? 21p. Perfect. So both the top and the bottom get multiplied by the same thing to get that. And then so we go, okay, so that's 35 plus 6 over 21p. And then they say, state any restrictions. So before we start looking to see if we cancel things out, we have to see if we have any restrictions. Yep, so we can go 21p cannot equal 0. So p cannot equal 0. Okay. So then we can keep simplifying this at this point. So we'll go, okay, 41 over 21p. Is there? No? Perfect. So for B, can someone put up their hand and let me know what the lowest common denominator is between 3y and 5? Justin? 15. Yeah. Okay, so we don't need your singing, Josh. Not that. Not that song. But he wasn't singing any math songs. Okay. Are we ready? Okay. So we go 3y on this side. And then we just get to multiply everything through. So 5 plus 6, 12, 18y all over 15y. And then before we start trying to simplify anything, that's when we go, okay, non-permissibles, exactly. So we go 15y cannot equal 0, y cannot equal 0. And then can this be simplified? 5 plus 18y over 15y. So a yes or a no? Perfect. So this is in the lowest form. We can't take a y out because there's no y with this 5, right? So whatever you divide, you have to be able to divide out of both terms. Okay, so D. What is our lowest common denominator? Squared. Okay, so the sides get multiplied by 5. These ones get multiplied by 2a. Okay, so we go 5 times a plus 7 minus 3 all over 10a squared. Okay, so then we just get to distribute that 5 through and distribute negative 3. So we'll go 5a plus 35 minus 6a over 10a squared. And we go 5a plus 35, and to get rid of our brackets, 6 minus 6a over 10a squared. Here's negative a plus 35. Okay, so for this one, I'd actually accept the answer written 3 different ways. I'd take this, I would also take 35 minus a over 10a squared. And I would take, if you take that negative sign out, and you get a minus 35. So there's 3 different ways you can write the answer. And it's important that you know like how to get these 3 different ways, because on a multiple choice, for example, they might have it written any of these 3 ways, and you have to be able to recognize that that's the same way that you have it written. Okay? But we also need our non-permissibles. So we can go 10, and then we get, yeah, a is not equal to 0. Okay, so in these examples coming up next. Okay, so example number 6, we'll do B and C. So it's the same thing. They want us to find the non-permissibles and then simplify. Okay, so we don't need any more singing this class. Say, Josh? Okay, so what is our lowest common denominator for B? How about someone puts up their hand? So these questions you can see are getting quite a bit more complicated now. But in this type, what you can do is you can look at it and be like, oh, well, the lowest common denominator is often just the 2 denominators multiplied together. And so you can just say it's 2y plus 5 multiplied by y minus 3. And for what's in the denominator, you don't even have to FOIL it. You can keep it just like that. So you can say that this is the lowest common denominator. Okay? No. Because how would you go, Sam, from, how would you make that equal to 2y plus 15? Right? You have to multiply it or divide it by something, and you can't do that. Okay? So from here we can go, okay, so what are our non-permissibles? We go 2y plus 5 is not equal to 0. Y minus 3 is not equal to 0. We get y is not equal negative 5 over 2. And y does not equal 3. Yeah, the factors of the denominator. And then so, because we know that our lowest common denominator is this guy right here, we know that we have to multiply the top and the bottom by y minus 3 on this side, and then 2y plus 5 for this one. So we get 4, y minus 3, minus 1, 2y plus 5. And then like that. Okay? So then from here, we can distribute that 4 and distribute that negative 1.